Hello and welcome to part 2 of our P4 uses of radiation. Now today we're going to be looking at uses of static electricity. So I hope you enjoy this and I'll see you at the end. Bye bye. Okay, so let's have a look at our objectives for this lesson. Now we're going to be looking at the uses of static electricity. So by the end of this lesson you should understand how static electricity can be used in these three methods. First one, defibrillators, the second one, spray paints, and the third one, smoke precipitators. So how does a defibrillator work? You've probably seen these all the time in TV programs like Casualty or Holby City, or if you're old enough to remember ER and programs like this. Now, when you have a heart that may have stopped, it needs an electrical impulse to get it started. Now what you have here is you have the heart which has stopped working, and you attach one paddle here and one paddle here. Now the two pads are electrically charged and they come into contact with the patient's chest. Now the defibrillator releases that charge and it goes towards the heart. Now the charge passes through the patient and it makes contact, and that hopefully will restart the heart. And it's important to know that most of our impulses like this are electrical impulses. Now you might see as well in this diagram that the person applying the defibrillator is insulated themselves here so that they don't get affected by the electric charge. So as well as trying to bring this poor guy alive, they need to ensure that they protect themselves. And you might hear them say, right, charging to however many volts, and then they shout clear to make sure that everybody is away so that they don't actually get themselves or any of their colleagues. Okay, so the second one we're going to look at is smoke precipitators. Now a smoke precipitator works like this. Now you can see coming up here you have smoke. Now smoke is actually tiny solid particles, although they behave like a gas. Is because they're so fine that they can actually behave in that way. They're also given lots of energy, so you can see each tiny dot here represents a solid particle. Now as they go through this red section here, what it does is it causes them to become positively charged. So as they go up through here, the dust particles become positively charged, and between here and here, the two plates inside the chimney, they become negatively charged. Now what this does is it causes the dust particles to move to the side where they become neutralized. Now once they're here, they can become earthed, which means they've lost that negative charge, and they can bind together to form large particles. Now what can happen is that when the large particles form, they can become heavy, that gravity causes them to fall down, or you can knock the metal plates and they will fall to the bottom of the chimney as well. Now just to recap this then, they become positively charged coming through here, move to here, clump together, and then fall back down again. That's a relatively high voltage here that causes them to become positively charged, and again there's quite a high voltage here. Now spray painting is the third and final way that we need to have a look at uses of static electricity. Now if we have a look at the car here that's being sprayed a lovely red colour, I think all cars are cooler if they're red. Now here we've got a spray gun, and we have the paint coming up through here. Now what happens is the paint travels up through here, and then when it leaves the gun it becomes negatively charged, so the gun causes it to become negative. Now, because you've got clumps of paint here, all these negative charges repel each other, which means that they spread out, which means you get a lot of movement. And you can see here that this movement of spray comes out in a quite a wide fashion, rather than a single beam going towards the material that you're painting. Now, you then need to make sure that the car is positively charged, and you can do that by removing the electrons from the car. Now, what this does is it means that the negative paint and the positive car will mean that the opposites are attracted, and this means that you neutralize the paint with the car. Now, that means that you get a really fine spray, and you also get a even coverage, because once it's neutralized it will no longer attract the negative paint, whereas once you get the positive and the negative, it will start to, or will attract, and it's really useful for making sure you get that even spray. Okay, so to review what we've just done, we have looked at how static electricity is used in defibrillators to restart a heart. We've looked at how they're used in reducing smoke pollution, and how they're used in spray painting. Anyway, I hope you've enjoyed the video, and I will see you next time. Bye bye.